Well, welcome class to our first screen recording. Today we're going to be looking at how to solve right triangles using trig. We're not going to be talking about the law of sines yet today. A quick reminder, in order to solve right triangles, it means we need to find all of the missing sides and angles of the triangle. And we're going to be remembering SOHCAHTOA, which is our trig functions allowing us to find many of these. So we're looking at triangle ABC. We know that angle A is 90 degrees. Label angle A immediately. You can call angles B and C, whichever you'd like. The side across from angle B is labeled side B, across from A is A, and across from C is side C. So we're then told that side B is 21 and that side A is 29. We have to find the remaining third side and both angles. To find side C, we'll use Pythagorean theorem, 21 squared plus c squared equals 29 squared. Keep in mind in this particular diagram, c is not the hypotenuse, it's one of the legs. 21 squared is 441 plus c squared equals 29 squared, which is 841. So c squared equals 400 and c is 20. Now, to find the missing angles, decide which angle you want to find first. I'm going to go for angle C and pick any of the two sides that you want to work with. Since we know all three of them at this point, any of them will be fine. I'm going to work with side 21, which is the side that is adjacent to C, and side 29, which was the hypotenuse. So to find angle C, I'm going to have to use my cosine. Cosine of angle C is the adjacent over the hypotenuse. Remember that to solve for an angle, you'll have to use inverse cosine of 21 over 29. And when I do inverse cosine, 21 divided by 29, I will get 43.6 degrees. Double check that your calculator is in degree mode if you want to be working with degrees. So once I know that angle C is 43.6 degrees, angles B and C are going to add up to 90. So 90 minus 43.6 is 46.4 degrees for side B. If we look at a second example, once again, we want to find the lengths of the two diagonals, and we're going to use this by actually trying to solve the triangles inside there. So the first thing we know is that the rhombus has a perimeter of 40. Remember that in a rhombus, all sides are equal, so each side of this rhombus is 10. We know that one of the interior angles is 70, so if we mark this angle as 70 degrees, a couple of things to remember about the diagonals. In a rhombus, the diagonals are perpendicular, so I know that I have 4 right angles in here. We know that the diagonals bisect each other, so this side is congruent to this one, and this side is congruent to this one. And we also know the diagonals bisect the angles. So if this angle was 70 degrees, that means this interior angle here is 35. If we look at one of those triangles, I'm going to just take this one on the top here and redraw it. We have a right triangle with an angle of 35 degrees, and we know one of the sides is 10. Since our job is to find the diagonals, we want to find this missing side, and we want to find this missing side. And remember that the diagonals are bisected, so once we find each of these sides, we can double that to find the full diagonals. Now back to the triangle. To find the missing sides, if I'm looking for this side, pick the angle that we are given, look at the side across from it that we're trying to find, and look at the side that we're given, which is the hypotenuse. So to find that missing side, we'll do sine of 35 degrees equals the opposite over the hypotenuse. To solve for the opposite side, I'll multiply both sides by 10. So the opposite side will be 10 times the sine of 35, which was 5.74. Now keep in mind, that's only giving us the top. We're going to double that to get the full diagonal. So if I multiply that by 2, my first diagonal is going to be 11.47, and this is in centimeters. To find my second side, Go back, look at the side we're looking at. Once again, use the angle that we're given. Use the one side that we were given. This time, though, we're looking at the adjacent side. So for this one, we'll do cosine of 35 degrees equals adjacent over hypotenuse. Again, multiply both sides by 10. The adjacent side is 10 times cosine 35, which is 8.19. But keep in mind, that's only the 1/2, so we need to double it for the full diagonal. And that's going to give us 16.38 centimeters for my second diagonal. Okay, now a quick talk about angle of elevation and angle of depression. Angle of elevation refers to, when we're talking about angle of elevation, this refers to the looking up from a horizontal distance. Okay, we always measure angles of elevation and depression from a horizontal distance. So for example, if you're looking at this individual standing here and you look at this horizontal distance and then the distance up to the sun, this angle is what we would call the angle of elevation. Likewise, an angle of depression would be an angle that is looking down, but again, that has to be from the horizontal. So I always encourage you when you're drawing your diagrams to draw in that horizontal. If, for example, somebody is standing on the top of the building and looking straight out, there's my horizontal, the angle that that person is looking down, that's the angle of depression. So now using these, this allows us to solve some problems like these two. A man climbs 213 meters up the side of a pyramid. So if we assume that this is the pyramid, this distance up the pyramid is 213 meters. He finds that the angle of depression back to his starting point is 52 degrees. So we need to imagine that the man is now standing at the top of the pyramid. Always draw that horizontal. He's looking straight out horizontally. The distance, the angle that he looks back down to his starting position, so that angle that he looks back down is my 52.6 degrees, right in there. We need to find out how high he is off the ground. One thing to remember, guys, is that height has to be perpendicular. So when I'm measuring that height, I'm looking for this perpendicular distance. So what we have here is a triangle. And just like we were doing before, we're going to look at trying to solve for some missing parts of this triangle. But remember that we don't have any angles inside the triangle right now. Now, a couple of things to keep in mind. First of all, if this horizontal distance and this horizontal distance are parallel to each other, then if you remember your geometry, these angles are what we are calling alternate interior angles, and these angles are going to be the same. So in this triangle, that angle down there is another 52.6 degrees. You could also look at it as these two angles up here at the top are forming a right angle. So if I know one of them is 52.6 degrees, I could do 90 minus 52.6 and find that that angle up at the top is 37.4 degrees. So ultimately, let's redraw that one triangle that we're looking at. We know that this is 213 meters. We know that this angle is 52.6. This angle is 37.4, and we know we have a right angle. And we're trying to find the height. So we're trying to find this distance. Pick whichever angle you want to use. I'll use this one. The distance we're finding is opposite that, and we are given the hypotenuse of the triangle. So to find that opposite side, I'll do sine of 52.6 degrees equals opposite over hypotenuse. To solve for the opposite side, we'll do sine of 52.6 degrees times 213. 6 degrees times 213, which means we are looking at a distance of 169.21 meters. Okay, one more example. This one takes a little bit more room, so I might encourage you to add in an extra page, or I guess it's just me adding in an extra page. So on this one, we got to draw a little bit more of the picture ourselves. We have a cell tower that's 150 feet tall, and it's on top of a mountain that's 1,200 feet above sea level. So if we start by drawing the mountain, Okay, we know that the mountain itself is 1,200 feet tall. And at the top of the mountain, there's this cell tower that is 150 feet tall. We want to know the angle of depression. I'm going to come back to that. From the top of the tower, so if we mark the top of the tower, to a cell phone user who is 5 horizontal miles away. So let's kind of go 5 miles away. Okay, I'm going to mark this as 5 miles. I could also mark that 5 miles down here at the bottom if I prefer. So that's 5 miles. We also know that the cell phone user is 400 feet above sea level. So the cell phone user must be standing on something. And we're going to mark him right here. And we know that this is 400 feet above sea level. Probably not drawn very well to scale. Okay. Our job is to find the angle of depression from the top of the tower to the cell phone user. So be very careful with your diagram. Here's the top of the tower. Always start with your horizontal. Then we're going to be looking straight down to the cell phone user down here, and we're looking for this angle of depression, which I'm going to call X. In this diagram, you want to find yourself a triangle, okay, specifically a right triangle. So I'm going to mark this one, and let's go down to where he is, and let's look at this triangle right here, okay? I'm not going to be able to find this outside angle right away, but what I can try to do is look for this angle right in here. Okay, keep in mind I know a couple of distances. For example, I know that this distance at the bottom is 5 miles. But since everything else is converted to feet, we're going to want to convert that 5 miles to feet as well. So 5 times 5,280. 5,280 is 26,400 feet. So we know this distance of 400 feet. We also know, if we're careful, this vertical distance. Okay, if you add together, sorry, I lost that. If you add together these two distances, that will give you the distance from the bottom of the mountain all the way to the top. But then we're going to have to subtract this distance. So 1,200 plus that 150 minus that 400 plus 150 minus 400, that gives us 950. Okay, so this is 950 feet. Now we have enough information looking at that triangle. If you need to, you can redraw it. We have a right triangle. This is 950. This is 26,400. We're going to solve for this angle. So since this is the angle we're looking for, this side is opposite. This side is adjacent. We're going to do tangent of angle Y is opposite 26,400 over adjacent. To solve for Y, we'll have to do inverse tangent of 26,400 over 950. And inverse tangent, 26,400 divided by 950 is about 87.9 degrees. Now keep in mind, that's the inside angle, 87.9 degrees. To find the outside angle, we're just going to subtract from 90, which I just hit the wrong button. And that's going to give us 2.06 degrees for that angle of depression, excuse me. Okay, final example that I just wanted to look at real quick. Solve the following triangle. Remember, that means that we want to find all the missing sides and all the missing angles. Well, we could easily find this missing angle because we know that all the sides add up to 180. So 180 minus 40 minus 45 tells us that this angle is 95. And that, class, is where we run into a problem. This is not a right triangle. We cannot use SOHCAHTOA on anything other than a right triangle, which means in one of our next lessons coming up, we're going to have to learn another strategy for solving this type of right triangle. So class, now I'd like you to spend a little bit of time practicing problems similar to the ones that we went over. Good luck, and email me with any questions that you might have.